Hello, this is Peggy from Team Honeycomb, and in today's presentation, I'm going to talk about Chapter 4 from the Android in Action book. The topics that I'll be further discussing is the Weather Report app. That sample or source code can be found on the author's website, intent and intent filters, custom URI, broadcast receiver class, IPC and AIDL, and a couple more examples to re-solidify the intent filter concept. And so going on to the first slide, how does the Weather Report app work? And to start, the Weather Report app uses the Yahoo Weather API to retrieve weather data, and display this information to the user. One of the key features is that it will alert the user for severe weather for certain locations or a specific location that the user will enter, and it's usually in the form of a zip code. In addition, the app uses a custom URI. It allows the user to access weather data. The URI is registered with a matching intent filter that allows any other application to invoke a weather report through an intent. The app includes 3 activities, and when I say activities, I mean the screens, more or less, that the app has on the Android. And in the next slide here, this is an example of an activity, and also the interface of how the weather report application will look on the Android device. This is figure 4.4. The 3 activities that's defined in the Android manifest file, for in particular the weather report app, there is the report view save locations activity, the report specify location activity, and the report view detail activity. The first one, report view saved activity. This activity brings up a screen that shows areas that you have saved. This allows you to check on an area without having to re-enter the zip code or information that's saved previously. The report specify location allows you to put in a text box a specific area or zip code. And the last one, report view details, actually the main activity. This is where it has the main screen. This is where it starts off with. And this app, it shows the weather conditions of the selected area. And after these activities are defined in the manifest file, there is also a receiver element in the manifest file. And that receiver element actually refers to a broadcast receiver class. There is an intent filter that's associated with it, and the intent that pairs up with the intent filter, it's mainly used for the boot completed action. In other words, this filter is used to invoke the weather alert service receiver class after the device has completed its boot up sequence. In the beginning of this presentation, we learned that this app is able to alert users for severe weather for a certain location. It's able to have this function because it defines a service. The service, it serves the role or does the job of specifically searching for updates on the severe weather alerts, and it does this in the background and then alerts through a notification to the user. I know I mentioned before about intent filters, so let's dive into that. What are intents? Intents are a way for something to get done without knowing exactly who will receive that intent. It more or less throws out, oh, I need this action to be done. And in response, usually there's a paired intent filter that pretty much says, I have what you need, I can do it, throws it back. And then it completes the whole process. Intent requests can only be handled by activities, broadcast receivers, and service components. Intents are late binding, as in they complete at runtime. They do not complete during the compile time. Intent, it requires an action and data, and the data being described by the URI object. I won't dive into that right now, but later on I'll further detail that. But it can have other attributes such as category, component, extra, and type. There's mainly 2 forms of intent. There's an implicit intent invocation and explicit intent invocation. And the first one, implicit, the platform determines which component should run the intent. As for the explicit, the code specifically names what component to handle the intent. And it also names the class and component name of the receiver. This is a must in the explicit intent invocation. Intents can be used to link the user to other applications on the phone, change one activity to another, and so on. Intents, they advertise their capabilities through the intent filter event element in the Android manifest XML file. Handling intents require inspection of the action, data, and categories of the intent attributes, and it finds a matching intent filter through that matching. And the intent filter, it actually has a few conditions that it has to fulfill. And some of the conditions that the action and category must match. The second thing is that the data type must match, or the combination of data scheme and authority and path must match. Data doesn't always necessarily have to be specified, but data can either be a MIME type or a combination of scheme, authority, and path. Intent filter classes describe what combination of type, scheme, authority, and path they accept. Some of the rules that Android has for intent matching is that 1. If a scheme is present and type is not present, intents with any type will match. 2. If any type is present and scheme is not present, intents with any scheme will match. 3. If neither a scheme nor a type is present, only intents with neither scheme or nor type will match. If an authority is specified, a scheme must also be specified. If a path is specified, a scheme and an authority must also be specified. Here on figure 4.3, there's an example that's pulled right off from the weather report app. As you see right here in the box that says intent object is made, and it has the parameters of intent.actionView. It has the action of view, and its data is URI.parse, and then the rest of the URI address, and semicolon. It throws on and it tells that it needs a particular action to be done. And then the program will actually go through the Android manifest file to find a matching intent. And on the top box here, you can see that the action matches, and the data parts of it are matching to what the intent is asking for. More or less the procedures that intent, it matches up with the intent filter and then goes on to late binding during the runtime. And in this cases, you probably will wonder, if there's multiple intent filter classes that match, who will decide? Well, for the most part, the platform does. Unless it's a user visible action like an activity, then the user can actually choose which intent to handle it, and usually that comes in a pop-up dialog box of some sort. But for non-visible action like broadcast, Android actually considers the declared priority of each intent filter, and it handles according to that intent priority order. And so here I have a picture of the listing 4.3, and it's pretty much the XML, the Android manifest XML file. And you can see all these intent filters in here that's waiting to get the okay from an intent to do its action, to do what it does. So moving on to custom URI. First, to understand a custom URI, we need to define what URIs are. URI stands for Uniform Resource Identifiers, or alternatively Uniform Resource Locators, URLs. Using effective URIs permits easy and quick access to information. The data component of an intent is expressed in the form of a URI and can be virtually any piece of information, such as a contact record, a website location, or a reference to a media clip. A URI can be an explicit MIME type or a combination of scheme, authority, and path. I'm sure you've seen this already, and it's not a coincidence. Earlier I mentioned that how data has to be of this similar explicit MIME type or a combination of scheme, authority, and path. That is because the URI object defines the data. Keep that in mind. And we go down further, and then we can see that this figure 4.2 breaks it down. You see the scheme, you see the authority, and you see the path. And that's how it's broken down. URI actually works in a similar way to URLs. URLs that uses in the web address bar when it wants to access a website. By using the actions and URIs shown in Table 4.2, which is shown below here, you can hook into a built-in map application, phone application, or browser application. And here's Table 4.2. Here are some of the common Android application intent, action, and URI combination. So the one we've been using is the intent action view. That's the one that we used in the previous example. In the weather reporter application, a custom URI is used to access the Yahoo Weather API. The custom URI is defined in the Android manifest file through an intent filter tag. And here's an example of that intent. You see that it has an action, a category, a data right below it, and the data is split up to the URI scheme and URI authority. Since the application supports custom URI, it will provide weather access. Android will launch the weather report application when it encounters a request for the custom URI. Once the onStart method of the main activity that a weather report uses is invoked, data is parsed from the URI and used to display a weather report.